Lightning and Thunder by Kate O'Donnell. Earth's atmosphere is full of gases. The most abundant gas in the atmosphere is nitrogen gas. Nitrogen gas is made up of two nitrogen atoms joined together. Oxygen gas, the next most abundant gas, is two oxygen atoms. Other gases in the atmosphere are made up of multiple elements. For example, carbon and oxygen atoms combine to form carbon dioxide. Electrons surround the nuclei of atoms in orbitals. When an atom gains or loses electrons, it gets a positive or negative charge. A positive charge comes from losing electrons, and a negative charge comes from gaining electrons. The atmosphere is also full of water molecules. Water molecules combine one atom of oxygen and two atoms of hydrogen. When water vapor condenses around tiny dust particles into liquid water, clouds form. Lightning forms inside of clouds. Scientists aren't sure how it happens, but they have some theories. One theory says that convection currents within clouds create electrical charges on particles within the cloud. Inside the cloud, warm water droplets rise and cold ice crystals sink. As the particles bump into each other, they knock electrons off of the atoms. The positively charged water droplets rise to the top of the cloud, and the negative electrons fall to the bottom of the cloud. The gases in the atmosphere act as an insulator between the charges. When the strength of the electric field between the positive and negative charges gets strong enough, it pulls electrons off of the air molecules and turns the insulator into a conductor. Electrons race through the ionized air, often called plasma, toward the positively charged water molecules. When they meet, the electrons jump into an empty spot in the positively charged atom's orbitals. The electrons have less energy when they are in an orbital, so the extra energy is released as heat and light. The law of conservation of energy says that energy cannot be created or destroyed, so when an electron loses energy, heat and light are usually released. The huge number of electrons joining orbitals and releasing heat and light creates lightning. When lightning strikes, it heats the air around it to an astounding 54,000 degrees Fahrenheit, 5 times hotter than the surface of the sun. The sudden intense heat creates a shock wave that pushes the surrounding air molecules away from the lightning. When the air cools, the molecules snap back, creating the thunder that accompanies lightning. The rumble that follows lightning is the air molecules vibrating back and forth after the shock wave. We see lightning before we hear thunder because light travels faster than sound. The sound of thunder travels about 1 mile every 5 seconds, so you can determine how far away lightning struck by counting between the flash of lightning and the thunder. The most common lightning is intra-cloud lightning. Positive and negative charges come together within the same cloud. Inter-cloud lightning happens when positive and negative charges from different clouds connect. The most dangerous form of lightning is cloud-to-ground lightning. This type of lightning happens when the negative charges at the bottom of the cloud attract positive charges from the ground. Cloud-to-ground lightning kills 2,000 people each year. The positive charges push toward the sky to meet the negatively charged cloud. As a result, lightning tends to hit the tallest object in an area. When lightning travels from a cloud to the ground, it follows a stepped leader. The stepped leader is the path of ionized air the electrons travel through to get to the ground. The path is not always a straight line because dust or other particles in the air can make some places ionize faster than others. Electrons follow the stepped leader path down to the ground. However, individual electrons do not travel the entire path. The electrons push into each other from atom to atom until the negative charge reaches the positive charge. When the negative charge reaches about 150 feet above the ground, the positive charge from the ground will race up to meet it. The upward surge of positive charge is called a streamer. The end.